Okay, and the lab on Monday, we will burn iron. Okay, so you have iron. Let's say 2.5 grams of iron. The first thing is going to be writing the equation of the burning iron. That is the first thing that we are going to do, okay? So, which is the equation of burning iron? Iron plus oxygen. The oxygen is a gas, so we put 2. And what we are going to obtain? Guys? Iron oxide. No. We have to put what we obtain, and we are going to obtain iron oxide. But the iron, if you remember or you saw the binary compounds that you are supposed to go to the videos and watch them, the iron compounds can be 2 different ones, since the oxidation number of the iron can be variable. So one of the compounds is iron 2 oxide, and the other one is iron 3 oxide, that the formula is this one. When we burn iron, we obtain the second one. So that is the formula of the iron oxide that we will obtain. Now you need to balance this. So when we have an odd number and we have even numbers here, the easiest thing to do is to put a 2 here. So I have 6 oxygens now and 4 irons. So I put a 4 here and a 3 here. Okay? So we have 4 of these, 6 of these atoms, 3 oxygen molecules, and 2 of these groups. Now, we will burn 2.5 grams of iron. So 2.5 grams of iron will be burned. How much iron oxide we are going to obtain in grams? What is the calculation that we need to do? We need first to calculate the what we are going to calculate is the masses of these, the masses of these, and the masses of these. So we are going to take the periodic table, as always, and we say iron is 55 point something. Let's round. 56 times 4 is 224. So 224 grams of iron are going to react with oxygen is 16 times 2 is 32 is the molar mass of the oxygen molecule, but we have that 3 times. Is 96 then, yes? 96 grams of this one, and that is going to give me iron 2, which is 112, 56 times 2, plus 16 times 3 is 48. That is going to be 160. That's the molar mass of the iron 2, oxygen 3. But we have 2 times that. Yes? So it's going to be 320 grams. Can we verify if that is right or wrong? We can add the masses before the arrow, the masses of the reactants, and it has to be the same as the masses of the products. Now look at this. I wrote with 2.5 grams how many grams of iron oxide I'm going to obtain. Look at what I'm going to do. I'm going to choose another color, and I say, I put a line here. Well, it's supposed to be a horizontal line, equal sign, and a line here. And now let me show you, highlight. I have grams, I need grams. I have grams, I need grams. So that is my proportion. I don't need to do anything. I just put, since I have my proportion there, I have X is equals to 2.5 grams of iron times 320 grams of iron 3 oxide divided by 224 grams of iron. I can cancel grams of iron and grams of iron, and my answer is going to be, doing the math here. Can somebody do that for me? Iron 2, oxygen 3. Or you do the math and you put it here, okay? Now, 3.57? Oh my, 57. Okay, yes? Now, look at this. Pay attention 1 second. When we burn things, we should obtain 3.57. So we are going to take the, iron wool. Okay, that is my iron wool. I'm gonna put it over the Bunsen burner or something like that. I'm getting good at drawing. Okay, so you burn it, and you are going to obtain a container with iron oxide. Okay, this is iron alone. Plus oxygen is going to give us iron oxide. When we measure this, how much would we obtain with 2.5 grams? 3.57? 3.57 grams. Actually, when we take the mass of the iron oxide and we put it on the balance, we're going to see that it's less than that. Why is less than that? Because maybe some of the iron didn't burn. Maybe some of the iron wool, since the iron wool is going to burn and the iron wool is very thin, some of them may escape, okay? They may falling from the one masses to the other one, so we are going to lose some of the iron because we are going to use a hair dryer to promote more air, okay, and to promote the reaction to go faster. So instead of 3.57, maybe we obtain 3 grams, okay? Now, how much percentage does this represent? If we had obtained this 3.57, that would represent 100% yield. Okay? But this number represents another one, and I assume that you know how to calculate percentages. So, the value that we calculate through the equation without measuring, okay, the mass at the end. The value that we calculate as if we are doing any word problem, that is going to be the theoretical yield. In this case, it's going to be 3.57 grams. Okay? Now, the actual yield, the one that we obtain, is going to be 3 grams. So we need to calculate how much is going to be the percentage that we obtain. So 3.57 is going to be 100%, yes? We need to calculate how much is 3, and this is grams, 3.0 grams, that is the mass that we may obtain, is going to be X. And that is going to give me, let's say, how much is that? 3 divided by 84%. What does that mean? That when we do the lab, we are missing 16% because of any reasons. Okay, we are going to analyze the reasons later. But sometimes we don't get the 100% that we should. And that is very important in industry, because many times you have impurities in the compounds, or maybe the temperature of the reaction is not completed or whatever, so you are not going to obtain 100%. And that is going to affect the value of the compound that we are obtaining and the costs as well. Okay, so that is going to be very important for us to remember.